So zone 1 was simple. Now we're going to move on to zone 2 and zone 3. So the first thing I want to do is actually draw a sketch of that sort of area. So here I'm going to start by drawing the edge of the house. There we go. That's not too bad. And we've got the two different levels of deck. So I'm going to first draw them. I'm going to try them draw them correctly in relationship to their colors. So I've got the one deck, which is the blue portion of the deck, and then immediately below that I have the beam. So let's draw the beam, and it will be 2 feet in. There we go. Again, I don't know what size it is, so I'm just drawing a generic beam as a blob, a big block or a big square. And then I'm going to draw the upper or the lower deck. And remember, it ties right into the side. Let me just undo that. I didn't like that line there. It ties right into the side of the deck. And that's important because that's how the connection will be. So this connection will be a Simpson strong tie joist hanger, whereas this simply sits right on top of it. And in this case, I'll have the rim board at one end. I'll have the rim board at the other end, and see the deck, like I mentioned to you, will sit on top of each other, but in fact, it's sitting on top of the beam. This is just an overhang. This is that 2-foot overhang right here. That's the center line of the beam, and see how the underside of the joist comes underneath that beam. And then there is a second beam, and this beam is lower, and it's located again within that 2-foot distance, and it supports the lower joist, whereas the center beam supports not only the lower joist but the upper joist. So this is our configuration. So when we're actually looking to title this, we're going to have a couple titles here. This up above here, this is our zone 2 area. So I'm going to mark it here. Zone 2, and we have a number of distances that are here, so let's mark down those distances. Once again, I try to use the center line of that beam, and sorry about that. I'm just trying to undo that. Let me erase that just so it's not messy on your screen there. I got some of that stuff there. And then I'm going to actually draw the center line of this beam, and that's located right about there. And now I can put in my joist spans. So I have the one joist span here, and I've got another joist span here, and the overhang. And with the overhang, there we go, these are my different dimensions. There we go. And now let's start marking this up. We have some dimensions here. I'm pulling right off of the drawing itself. That one over here is 12 foot 8 1/4. I'm just going to make sure. So let me just zoom in on this here and make sure I've got the right dimension on that. Let's see if I got the right dimension on that one. 12 foot 8 1/4, and the lower one is a dimension that's off the page. I'm going to take a look at my CAD drawing to get that one, and then I'll mark it down as well. So if I go to my CAD drawing here, the lower section here, let me see where that number gets generated, is 9 foot 3 3/4 inches. Okay, let's go back to our drawing here. So the first one is 12 8 1/4. So let me go in here and mark that up. So these are the spans, 12 foot 8 1/4. And the other one was, sorry, I just want to make sure, 9 foot 3 and 3/4. So this, oops, sorry, it's flipping back and forth here, is 9'3" and 3/4 inch. And this is my 2-foot overhang. So those are my spans. And again, these are pretty easy to calculate. We just go to the span table. You have to make sure your notes are clear. This is zone 2. And right beside it here is zone 4. So when we're actually doing the calculations in here, I'm going to just keep my black pencil on. The beam here, this particular beam over here, is beam 2. And the beam down here is beam number 3. So for the joist, which is 12 foot 8 1/4 inch, if I go to the span tables that we looked at a bit earlier on here, let me pull that up. So 12 foot 8 1/4, sorry about that, 12 foot 8 1/4. Let's take a look at that. I'm going to go to my floor joists. 12 foot 8 1/4. This one is fine at 16 inches on center. This one's no good, so I'm going to trash that. That was from the previous example. This one we'd have to use that particular one. 12 foot 8 1/4. Once again, this one here is also no good. We'd have to go with 14 feet and bridging and strapping. So there's no advantage to going over top of the very first selection, 2 foot 10 at 16 inch centers with strapping only. It meets the requirement. This one's a touch large. Well, what if we were to actually go with 12 inch centers instead? Is there an advantage? 12 foot 8 1/4. So here, no, not with strapping only. 12 foot 5, that's too tight. 13 foot 1. This one may meet the requirement. And it may be a good choice. This at 12 inches on center is a smaller piece of lumber than this one. So let's scrap this one. We don't need that one. Those are our 3 choices that we can do in this particular project. All right, so again, we mark down all of them, and then later on when we have every single calculation, we will then determine by virtue of uniformity where it's most consistent. We then determine exactly which one we're going to pick. So the first one we had was the choices were according to the OBC. We could go with 2 by looks like 10s at 16, and that had a maximum size of 12 foot 11. Now that's pretty close to 8 1/4, so that's why we went to the next size for the OBC, was a 2 by 10 inch at 16 inches on center. This one was with bridging, and that one had a maximum span of 13 foot 8, well within our requirements. And the third one we picked was 2 by 8 at 12 inches on center, and that one was with bridging and strapping, and that allowed us to go 13 feet 1 inch. You can see at this point it's premature to pick one, because it may be that most of the deck I can get away with 2 by 8s, and therefore I want to consistently buy 2 by 8s, and that just makes it for a simple project, and not having to note on the drawing where the 2 by 10s versus the 2 by 8s, just the center markings. Whereas if everything ends up being 2 by 10 except for this one, then I will go with 2 by 10s. So these are decisions we're going to make along the way. Now let's take a look at the supported length, and I'm going to change the color marker just because it will become a bit clearer. And what we need to do again is look at the center line of that and the center line of this one. And our supported length for this beam here is this length right across here from there to here. And I'm going to keep drawing right to the end because this is the supported length for beam 3. So for beam 2, it's half of 12 foot 8, which is 6 feet 4 inches. I'm going to ignore that 1/4 inch marking, and half of 9 foot, more or less 4. So I'm going to go with 4.5 feet here, 4 inches. That's 4 foot 8 inches plus 4 foot 8 inches. You notice I'm rounding the numbers off just to make the calculation a bit easier. What about this one here? Again, 9 foot 3 is 4 foot 6 plus 2. That's 4 foot 8. And I have to include the overhang, 2 feet. It's not wanting to cooperate. There we go. So this supported length in beam number 2, and I'm going to write this down on here. So beam 2. The supported length equals 6 feet 4 inches plus 4 foot 8 inch, which equals 10 feet 11 feet, 11 feet 0 inches. So let's see what the charts say about that one. Okay, so I'm going to look at the beam chart over here. Let's slide that one over. If I move too fast, then it has some challenges here. I just got to move back. There we go. So let's go with the beam chart here. There we go. So the first supported length is 11 foot 0 inches. Okay, so let's get rid of some of the information we had from our first example. We can't use any of that. It's going to be all different. So let's trash all this. So 11 foot, I can't use 910. I have to use this for my supported length. Awesome. What are the column spaces? Okay, so in our example in beam 2, the column to column space is what distance? There's our maximum one right there, which is 12 foot 11 and it looks like 3/8 or 7/8. Let me just refer to the CAD drawing. Foot 11 and 1/8. Okay, let's minimize that. So my column to, oops, sorry about that. My column to column spacing on this project is 12 foot 8 inches. I'm removing the 1/8 of an inch because on site you're not going to be able to, 12 foot 11 inches. You're not going to be able to correct that anyways or create to that accuracy. So that's my existing column to column spacing. What does it say on the Ontario Building Code that we could actually use? Well, let's refer to that. Now you can see I've mentioned several times that you got to print this stuff out. You're going to be referring back and forth to so many different pages at the same time. It's impossible to follow along. So 12 foot 11, what are our choices here? I got to exceed that. Well, I got one here and I've got one here. I don't have too many options here. So you can see we're really starting to max out that space. But remember, this beam supports this deck and that deck. It supports a lot of weight. We're trying to hit that magical number between 12 and 14 feet. And you can see here it can barely make those two values. So at 12 foot 11, my only options here are 13 foot 3. So that is 5 2x10s. Or 14 foot 1, which is 4 2x12s. So here we go. That's how we're going to note it down here. So according to the OVC, it says that I can have Let me just pull up that table once again. I'm going to have to move the table over. I can't run both programs at the same time. It buggers up the video feed here. So sorry about this. I am really maxing out this computer's capability to be able to do all this at one time. So I have to pull up the table very slowly. There we go. And I'm going to pull that table up and just move it over. Beam. Those were our values. So I'm just going to slide this over so it doesn't sort of stall my computer screen here. There we go. So here are my values, OBC, and follow along. And that's why I say you got to print it off, mark it off, so you can actually see where we're doing. The actual supported length by the building code is 11 feet 10 inches. Now I'm marking that down here because that's the OBC value. This is our supported length value, which simply means I have a little bit of play where I can move the beam and actually increase this number. Okay, and that's important because the beam may not necessarily be able to be placed exactly where it is. My column and spacing is here. So the OBC for the supported length of 11 feet 10 inches gives me the following options. I can go with 5 2 by 10 inch, and that has a maximum column-to-column spacing of 13 feet 3 inches. Or I can go with 4 2 by 12s, and that will give me a maximum column spacing of 14 feet 1 inch. So which do I pick? I don't know. I've got to calculate every joist, every beam, and see where the commonality are between them all. If they all happen to work with 2 by 10s, that's what I'm going to buy is 2 by 10s, regardless of what a 2 by 12 will do in this instance, regardless of what a 2 by 8 will do in this instance. I base it on similarity. So now I've calculated beam 2. Beam 3 I know is going to be much smaller because the supported length is only 6'8", which is the first level of the chart. And I do it for each and every value that I have on this table, and that will give me my calculations for each one. So going back to the AutoCAD project that I have here, if I take a look at this particular project, when I finally come down to putting in all these sizes, it's all based on me determining what were the common numbers. Now even then I couldn't get exactly the same, but here's my zone, my span, my beam selection, and then my joist selection, and I'll do that for each and every item in this particular project. This is what's going to be required as part of your final assembly of work. So it is a process. It is not simple. I want to help you with identifying the sketch design of your beams and your zones, and in that we'll identify the spans and what the sections will look like. Basically, you have two different types of sections that you can be drawing in this particular project, as I have shown here. So the one section will have a beam that has joists tied into the side and above, or a simple beam and joist where the ledger here is simply tied into the house. Apologize for the scribbleness. It's just the drawing program I'm using here doesn't allow me to do some very neat lettering or writing. And like I said, as long as you can follow this, you should be fine.